Alright, welcome to my video on VLAN trunking. This video is a series of videos on VLANs and VLAN trunking that were done by East Carolina University students in the Cisco Academy. The configuration that follows is meant for Cisco switches, but the theory applies to all networking devices. So if you missed the video on VLANs, here's what a VLAN is. VLAN stands for a Virtual Local Area Network, or a virtual LAN. A VLAN is a group of logically connected or logically networked devices, such as a set of networked computers and printers for a department or a building floor. VLANs can also separate network guests and trusted user traffic into separate VLANs and keep things safe. And a VLAN is also a logically separate subnetwork. Devices on VLAN 20, for example, and VLAN 30 can't communicate between each other without a Layer 3 device such as a router. So what are VLAN trunks? VLAN trunks are like funnels where multiple VLANs can travel over one physical media. It's kind of similar to bridges with multiple highways over rivers around Washington, D.C. And a VLAN is defined as a point-to-point link between one or more Ethernet switch interfaces and another networking device such as a router or a switch, which can carry the traffic of multiple VLANs over a single link. About how to picture how a VLAN trunk works. Think of it like this. Imagine a section of highway where two highways run along the same road at the same time. One example in North Carolina is when Highway 55 and Highway 401 combine to the same road for many miles and then separate down the road back into their individual highways. Like I said, commonly highways converge over bridges, and the same theory applies to networks. So let's look again at our example topology. We have four VLANs. VLAN 10 is accounting, VLAN 13 is guest, VLAN 20 is research and development, and VLAN 30 is sales. On the left is a corporate office, and on the right is a remote site. Let's say it's a nearby building that was close enough to run cabling to and didn't need a WAN. I've circled the devices on each VLAN with a corresponding color: gold for accounting, red for guests, blue for R&D, and black for sales. Without VLAN trunks, we would have to dedicate one port on each switch and one physical media connection per VLAN between each device. So if I had two switches and four VLANs, I'd have to use 4 physical cables and 8 switch ports. For a few VLANs, this may not be a problem, but as your VLAN numbers grow, you would lose more and more ports. This isn't really practical past 2 or 3 VLANs, and really shouldn't even be done this way with just 2 medium traffic VLANs. The only reason to separate VLANs is if you have a high traffic VLAN. Now here is VLAN trunking illustrated. With VLAN trunks, we have to dedicate just one port on each switch and one physical media connection for all VLANs. As you can see in the illustration, one connection now carries traffic for VLAN 10, 13, 20, and 30. In this scenario, one physical connection carries the traffic of VLAN 10, 13, 20, and 30. This saves us 3 cables and 6 switch ports, allowing 6 more devices on both sides to be connected to the switch. Now, here's how to configure trunks. After you've configured the VLANs on this switch using the VLAN number and then name commands, we need to identify which ports are going to be used to connect the two devices. For our case, we chose a high-speed port, and for this switch we have gigabit port 11. So on the command line, we type interface gigabit 1/1, and that takes us to the config interface mode, in which we type switch port mode trunk and enter, which sets that switch port to the trunking mode. and then we type switch port trunk native VLAN and a number. In our case, we use 13, and we'll discuss that later. And now that we've configured the interface, we simply type exit, and we're back to the config mode. Now the gigabit port is configured to combine all the VLAN traffic onto that line. Now to complete the same on the opposite side, we simply find the interface and change it to trunking mode, add the same native VLAN, it's very important to be the same, and exit. It's also important to note that both of those should be enabled using the no shut command. Now, the native VLAN 13, that specifies what to do with traffic that doesn't originate from a VLAN, such as control traffic, which is dropped if it doesn't contain a VLAN tag. More on that later. Now, once VLAN trunking is configured, all the VLANs will transmit their data across a single trunk line connection. As you can see here, now that they're configured, our 4 lines have become 1, and traffic for VLAN 10, 13, 20, and 30 now goes across this one connection. So how does VLAN trunking work? Well, today's trunking protocol relies on a standard called IEEE 802.1q. And it's often referred to as .1q, especially in the Cisco command line. Previously, trunking relied on a Cisco proprietary standard called ISL, which would discard untagged traffic, and that's not exactly what you want to do in many cases. .1q allows tagged and untraffic to be transmitted. Untagged traffic, such as what may originate from a switch with no .1q support, will be tagged with the native VLAN and will allow that data to be forwarded across the network. VLAN trunking works by tagging a frame with its VLAN ID. It adds the VLAN ID into the 802.1q encapsulation header, which adds a tag to the Ethernet frame. For example, if a sales computer sends out a packet of data, the switch sees that it came from a port designated as VLAN 30. It then, using 802.1q encapsulation, changes the ether type value in the Ethernet header to 8x8100 in hex format, which refers to the tag protocol ID, and that's where the VLAN ID is placed. On the opposite end, which is typically a switch, it reads this tag control information and it segregates that data onto the desired VLAN and searches for the destination device. And that is VLAN trunking. I hope you've learned something about VLAN trunking, or if you're using this video as a refresher, I hope you've now remembered all that you needed to remember about VLANs and VLAN trunking.